In my book, Material Space Theory, The Collapse of the Theories of Einstein, Bohr and Maxwell, which you can find linked right now in the description below and in the first pinned comment, I present the ultimate collapse of modern astrophysics' biggest illusion, dark matter. This film is the definitive mechanical proof of that collapse, exposing the fundamental falsehood of Einstein's special and general relativity. For decades, scientists have observed that galaxies rotate far too fast at their outer edges. According to the gravitational laws of Einstein and Newton, these galaxies should fly apart. To save their broken models, mainstream physics invented an invisible, magical substance called dark matter. They claim it fills the universe, yet it cannot be seen, touched, or detected. But what if there is no missing matter? What if the mistake lies in our fundamental understanding of space itself? In material space theory, space is a physical material substrate. It has density and it has internal viscosity. Gravity is the physical, accelerated inward flow of this substrate toward a central mass, moving exactly at the local escape velocity. Mass is simply the process of continuously absorbing this space, and matter consists of stable bound states of it. Light is carried by this moving substrate like a boat on a rushing river. To prove this mathematically, we model this spatial inflow as a compressible fluid using the Navier-Stokes equation. Because the flow is three-dimensional and spherical, we apply the conservation of space flux. This naturally reveals that the density of material space drops off as the inverse fractional power of the radius, specifically to the power of 1.5. Now, let's look at what happens in the flat midplane of a spinning galaxy, when we break down the substrate's acceleration into its radial components. Something extraordinary happens. The classical Newtonian gravity term and part of the space's inward acceleration cancel each other out exactly on both sides of the equation. What remains is a clean, beautiful balance, driven entirely by spatial viscosity. Because the substrate's density thins out at larger distances, its kinematic viscosity naturally scales up, growing with the radius to the power of 1.5. When you multiply this expanding viscosity by the spatial layout of the inflow, the distance terms perfectly balance out. At the far edges of the galaxy, the outer orbital velocity flattens into a complete constant. If you square this relation, the outer velocity to the fourth power becomes strictly proportional to the visible baryonic mass and a universal acceleration scale. Without assuming a single particle of invisible dark matter, the fluid mechanics of space naturally and flawlessly delivers the famous baryonic Tully-Fisher relation. When we run the numbers across dwarf galaxies, Milky Way-like systems, and massive spirals, the math perfectly predicts their real observed rotation speeds. Now, a critical mind will ask, if space has viscosity, why don't the planets in our solar system experience this drag and spiral into the Sun? The answer lies in the mass distribution and the math of scaling. In our solar system, the mass is concentrated in one single point, the Sun, unlike a galaxy where mass is spread across tens of kiloparsecs. Because of this, the solar inflow cannot simply inherit the galactic acceleration scale. It must possess its own viscosity amplitude, determined entirely by the local solar space flux. Near the Sun, the classical Newtonian gravitational pull is immensely strong, dropping off very fast with the square of the distance. The spatial viscous acceleration, however, drops off much slower, only with the inverse of the distance. When you calculate the ratio of this viscous force to Newtonian gravity at Earth's orbit, it is less than 1/10,000,000th. At Saturn, it is less than 1/1,000,000th. These numbers are so microscopically small that they are completely invisible to our current planetary tracking. The planets simply ride the accelerated inflow of space, completely undisturbed by its internal viscosity. But everything changes when we look at a fast, lightweight, artificial spacecraft on an escape trajectory leaving the solar system. As a probe travels past 20, 30, or 40 astronomical units, the Sun's Newtonian grip drops off drastically because of that inverse square law. But the viscous reinforcement term, decreasing only as 1/r, fades much slower. The ratio between them grows linearly with distance. In the deep outer solar system, the Newtonian pull weakens enough for this subtle, long-range viscous acceleration to finally reveal itself. By looking at the tracking data of the Pioneer 10 and 11 spacecraft, we can pinpoint the exact value of this local solar viscous amplitude. It comes out to roughly 3,200 meters squared per second squared. This static background value produces an acceleration that perfectly matches the quiet outer regions. Furthermore, because the spacecraft is moving rapidly outward against a medium flowing inward, a convective coupling occurs. This physical interaction between the probe's motion and the viscous substrate enhances the effective acceleration by a factor of order unity. The math yields an anomalous inward deceleration of 5 to 10 times 10 to the minus 10th meters per second squared. This is the exact observed value of the Pioneer anomaly. It is the literal physical fingerprint of material space acting in our own cosmic backyard. The exact same underlying substrate physics governs both the vast rotation of galaxies and the deep space trajectories of our probes. Each system simply commands its own characteristic scale based on its geometry and mass. No dark matter, no fictional placeholders, just real fluid mechanics. If you are ready to see the complete rigorous mathematical framework, including every single equation, step, and boundary condition, it is all laid out in my book, Material Space Theory: The Collapse of the Theories of Einstein, Bohr, and Maxwell. Available right now on Amazon. In a moment, I am going to step away. The screen will transition to show the exact, unedited mathematical derivations directly from the text, so you can study their proof yourself. This marks the beginning of our next video, where we will thoroughly break down every single equation, step by step. If you're ready to break free from the dogmas of modern physics, hit that subscribe button. Grab your copy of the book through the link in the description below and enjoy the derivation.